There's a lot more to drilling a composite part than you might think. Because drilling prepares parts for assembly, and assembly must be very precise, several critical steps are involved. After the process documentation is checked, the hole pattern for the part is carefully and precisely laid out. The parts to be assembled are aligned and marked. The proper drill bits, both size and type, are selected, and the pilot holes are drilled. Then the final holes are drilled and smoothed. Some holes are finished with a conventional countersink, or a partial countersink called a fillet, and temporary fasteners are installed. There's a lot to know about each step in the drilling process, and it all starts with the documentation. The process documentation must be checked for the specific parts to be joined, the type, size, and number of fasteners to be used, and a lot of information about the placement of the holes for the fasteners, including how far the fasteners are from the edges of the part. That's edge distance, or ED. How far the fasteners are from each other, called FS, for fastener spacing. And how far the rows of fasteners are from each other. That's known as RS, for row spacing. The documentation also shows us the individual tolerances for ED, FS, and RS. That's how far off position each can be without ruining the part. With this information in hand, we're ready to align and mark the components that make up our assembly. These components may be composites, or a mix of composites and metal. One of the documents, an engineering drawing, shows us how the components fit together. After they're aligned and double-checked, it's time to index mark each component for proper orientation. A special carbon fiber-approved pencil or marker is used for composites, and a designated soft-tip marker for metal. The same markers can now be used to lay out the hole pattern. Following the specifications in the documentation, we measure and mark the edge distance along one edge of the part, then along the opposite side. Then mark the edge distance in from the remaining sides on the ends of those lines. This edge distance is measured from the center of each fastener, so each hole will be centered on the ED line. Now we can calculate exact fastener placement. Keep in mind that any line that has equally spaced points from end to end will have one less space than it has points. For instance, 10 points means 9 spaces in between the points. The drawing shows us how many fasteners to use on a particular ED line. All we have to do is measure our usable line length, that's from ED intersection to ED intersection, and divide that length by the number of fasteners minus 1. If we have 10 fasteners, we divide by 9. That gives us our FS, fastener spacing. The first fastener and drill mark is at the ED intersection at one end of the first ED line. Now, measuring from our original reference, the part edge, ED plus FS gives us the second mark. Plus FS again gives us the third, and so on. By keeping the rule in fixed position, we can be certain that each measurement is exact. Moving the rule would cause tiny errors with each shift, an effect known as tolerance buildup. Once all fastener center points have been marked and checked, we're ready to select our drill bits. The bits must be compatible with all the materials in the stack-up. Drilling puts a lot of stress on composites. The wrong type bit or the wrong speed or even the wrong feed rate can cause splintering, chipping, delamination, or overheating. It can even melt the resin. If the work instructions don't specify what type of bit to use, the operator will have to choose based on the materials in the part. Most conventional composite or composite and metal assemblies will require either carbide or PCD bits, that's polycrystalline diamond. Non-metallic carbon fiber assemblies may call for long helix left-hand drill reamers. To ensure minimal strain on the composite material, we must also use the right size bits. A hole for a typical small fastener might require 2 or 3 bits, one to start the hole and bore the pilot, and then 1 or 2 to gradually size the hole up to its rough finished diameter. The larger the rough finished hole, the more intermediate bits are needed. To make sure bits don't cause damage or injury as they exit the back side of a part, we often use a drill stop with a bushing. The stop is a collar that's attached to a bit at the target depth, and the bushing helps guide the bit while protecting the part from the spinning stop. If the bottom layer where the bit exits is composite, a drill backer is sometimes required to prevent delamination or splintering of the composite material. In a finished part, all the fasteners must lie flat on the composite surface. If a hole is accidentally drilled on an angle instead of straight, the head of the fastener can't lie flat. It will be tipped up on one edge, creating a poor mechanical joint and leading to fastener failure. To ensure that each hole is truly perpendicular to the composite surface, we regularly use drill cups. When a drill cup is fitted with a properly sized bushing, one that exactly matches the bit diameter, the cup serves as a drill guide, keeping the hole plumb and straight. A good hole begins with a good drill start. A drill start is the small dimple made with the tip of the bit that keeps the bit from skating off the mark as pressure is applied. To create a drill start, the bit is rotated until the tip is easily visible. And, with the bit held at a 45-degree angle to the part's surface, the tip of the bit is placed directly on the first hole center mark. Then the bit and motor are brought to a perpendicular position over the mark, and the drill chuck is rotated by hand to create a clean, well-positioned drill start. After all the drill starts are completed and checked, we're ready for the pilot holes. With a drill stop already installed on the bit, a drill cup with a right-sized bushing is slid over the bit and down to the stop. The tip of the bit is placed directly on the first hole drill start. With the bit and motor in a perpendicular position, the drill cup is slid down the bit and brought to rest evenly on the composite surface. Then, with the cup held firmly against the surface, the drill is started and the bit is slowly fed into the new hole and down to the stop. After all the holes have been drilled and sized to specifications, they're ready to be finished. The first step in finishing is deburring. Deburring creates what's called a net condition, a smooth part surface without splinters, burrs, or delamination. Holes in composites are deburred by hand using a fine grit abrasive paper or pad. A few twists of a finger or thumb directly over the hole are usually enough. Deburring holes in metal requires a countersink cutter with a microstop cage. The countersink actually bevels the top edge of the hole, while the stop ensures that the cut isn't too deep. For flush fasteners, a traditional countersink cut will let the head of the fastener sit down in the part, level with the surface. A countersink is also used in another hole finishing step for metal components that's called fillet relief. Many fasteners have curved or ramped shoulders where the head of the pin transitions to the shank. This part of the pin is called the fillet. By cutting the top edge of the hole back with a countersink, we create room for the fillet to seat in the hole, and that means the head of the fastener can lie flat against the part surface. This creates a more aerodynamic part surface and a better mechanical joint while relieving stress on the composite directly around the fillet. Drilling stack-ups requires a few specialized steps. All of the components of a stack-up must be carefully aligned before drilling and firmly clamped together. Holes are drilled in a sequence that helps keep all components aligned. The first hole in the first row is drilled and rough finished. Then a properly sized Cleco fastener is temporarily installed in the hole to keep the components aligned. Then the last hole in the last row, diagonally opposite the first, is drilled and finished, and a Cleco is installed in that hole. Then the remaining corners can be drilled and fastened. The components are now locked in alignment, so the clamps can be removed and the remaining holes can be drilled and fastened with Clecos in a regular sequence. Only one more step is needed to finish the holes for assembly: final drill and ream. Standard bits and drill cups are used to rough size each hole 8/1000ths of an inch smaller than its specified final size. A special reamer bit is then used to smooth and enlarge the hole to its precise finished diameter. When all the holes have been reamed to the proper size and spring Lecos installed, the part is ready for final assembly.